I don't know, vectors and dimensions and tokens and stuff like that. So I don't want to assume that all our viewers know all these basics. So let's like quickly get these basics out of the picture so we can talk about the real stuff, like how it works. So what exactly is vector search? What exactly do we mean by embeddings? We can probably take an example and talk about it and explain in really simple terms what they mean.
Yeah. First off, I use vectors and embedding somewhat interchangeably. I think there might be a more precise definition for each, but for all intents and purposes, we can talk about them as the same.
Yeah.
Um, and what are they? Well, LLMs are very, very good at knowing what data is relevant to other data. That's why they're next token predictors, right? So, you have hello, and it thinks that there's a very high probability that the next word is going to be world. And that's fundamentally what an LLM is able to do. And one of the internal representation of that are a bunch of floating point numbers. And you could think about them in the simplest way that if you had a two-dimensional point and you train the model to figure out that points that are close to each other in space are also semantically close to each other. So what I mean by that is that you take a banana and you take an apple and you train a model to say, well, they're pretty close. They're not quite the same. Like a pear is maybe closer to an apple than a banana, but they're pretty close. I mean, they're at least closer than computer is to any of those words. Well, now you end up with a coordinate system, right? And it's easiest to intuit this in 2 dimensions. So you end up with a coordinate system and you will end up with essentially these clusters, right? There's going to be a fruit cluster. There's going to be a electronics cluster. There's going to be a whatever animal cluster, whatever, right? So that information that is close in the coordinate system have coordinates or are also semantically close in the real world, right? So that's really what a vector or embedding is. It's that it's a point in a coordinate system where stuff that is related to other stuff is close, right? The easiest thing is just to think about the Euclidean distance between the 2 points. So
Yeah.
that's just what you did in, geometry in 6th grade or whatever, right? LLMs are very, very good at taking information and turning them into a bunch of a long floating point representation in this vector space. The reason we call it vector space and not a point is because it's not in 2 dimensions. It's in maybe some multiple of 64, 128, 384, whatever, often thousands of dimensions. And you can think about each of these dimensions maybe representing a real thing.